Our webinar about Specify 7 for Natural Science Collection data is given by Franziska Böttger, data manager in the Museum für Naturkunde Berlin.
I'm excited to share with you how we use Specify not just as a tool, but as an integral part of our digital catalog infrastructure. Today, we will focus less on individual features of the software and more on the workflows and strategies we've developed around it, including how we handle data integration, support, and quality assurance. You see a timeline here with the 6 main parts we will cover. What is Specify? A short introduction into the tool itself. Why Specify at the Museum für Naturkunde Berlin? Integration processes, how we are building structured workflows with checklists and pipelines. Specify as a data repository, its role in the larger infrastructure and how it connects to other systems. Support and QA, strategies for long-term maintenance, error handling, and training. And last but not least, lessons learned. Before we dive into the processes we've developed at the museum, let me give you a brief introduction into Specify itself. The Specify Collection Consortium is located in Kansas, Texas, has about 30 years of experience in the field of scientific data management, and currently collaborates with over 530 collections in 44 countries around the globe. Specify is a specialized collection management software used in natural history institutions worldwide. It's designed to store and manage data about specimen, taxonomy, collection localities, associated media like images or documents, loans, storage, and more. One of the reasons it's so widely used is its flexibility. It can be used and customized to fit many different disciplines, from zoology to paleontology to botany. Specify supports international meta standards like Darwin Core, and it also integrates with external platforms like GBIF. The latest version, Specify 7, is web-based and designed for collaboration, which is especially useful for institutions like ours, with many users working across departments. So when I speak about integration processes or our support systems, just keep in mind, Specify is not a one-size-fits-all database. It's a toolkit that can be shaped around institutions' needs. To give you a brief insight into the dimensions and capabilities of Specify, here you see the Specify table scheme, the core of its data structure. It illustrates how various data types like collection objects, taxonomy, localities, media, and loans are interconnected. This relational model enables us to represent complex relationships and manage data efficiently. The schema's flexibility also allows us to accommodate specific requirements of our collections and make adjustments to meet diverse needs. Before we delve deeper into the processes and the structures, I'd like to provide you with a brief overview of Specify's user interface. This slide displays the homepage of Specify 7, our web-based collection management system. The interface is designed to be both intuitive and customizable. Users can tailor their homepage to quickly access frequently used features such as data entry, queries, or reports. Additionally, Specify 7 adheres to international accessibility standards, ensuring the software is optimized for users with diverse needs. This combination of flexibility and user-friendliness enables us to work with our collections, data efficiently and effectively. As you may have noticed, the different colors in the Specify logo and this and the last slides, I actually use those color settings within Specify to visually distinguish between collections. It's a small feature, but incredibly helpful for quick orientation. So, why did we choose Specify as our core system at the museum? First, it's a centralized data hub. We are dealing with over 30 million specimens in over 30 collections, from fossils and minerals to zoological and molecular collections. Specify allows us to bring all this data together in a single platform. It replaces outdated legacy systems and fragmented record keeping that had grown over decades. With Specify, we are finally moving toward a cohesive, centralized digital collection. Second, it's customizable for research. Specify is highly adaptable. It supports international standards like Darwin Core or GBIF, but it's also flexible enough to handle discipline-specific metadata, whether that's for DNA samples, CT scans, or 3D models. That makes it a powerful tool for research-driven institutions like ours. Third, it's integration friendly. Thanks to its API structure, Specify can connect to a range of other systems. We will link it with our digital asset management system for media files, with GIS tools for georeferencing, and we are also feeding data into global portals like GBIF and Europeana. This ensures our data is not only structured, but also shareable. And finally, the collaborative workflows. Specify supports role-based access, which means curators, technicians, researchers all see and do what's relevant to their work. To ensure consistency, we use standardized checklists for data entry, helping everyone stay aligned across teams and disciplines. In short, Specify offers us a future-ready infrastructure, not just for storing data, but for making it usable, visible, and sustainable across the entire museum. Let's now take a closer look at how we are building structured integration processes for working with Specify at the museum. Why structure? Because without clear workflows, data chaos is inevitable, especially when working with millions of records and multiple departments. Our aim was to improve efficiency, reduce errors, and ensure consistency across the board. We have created detailed checklists for every major step in the integration process. One example is our data cleaning checklist. This includes key criteria like completeness of metadata, controlled vocabulary usage, and format standardization. These checklists help team members stay on track and avoid critical errors before data enters the system. We also define clear responsibilities: who enters the data, who reviews it, who manages technical tasks, who takes care of problems. By mapping this out, often using a simple org chart or role table, we have been able to streamline collaboration and avoid overlap or confusion. Where possible, we will introduce semi-automated pipelines. For example, a collection can be processed through a pipeline that takes CSV data, runs it through validation checks, and imports it into Specify. This saves time and allows us to focus human effort on review and refinement. Lastly, Specify connects well with other tools. Through APIs and plugins, we link it with GIS software for georeferencing, our digital asset management system for media files, and other platforms. These connections are crucial for making the data dynamic, interconnected, and future-ready. Overall, our integration processes combine clarity, accountability, and technical flexibility, a foundation for sustainable data management. This slide provides an overview of our comprehensive plan for implementing Specify at the Natural History Museum. We have divided the integration of Specify into the museum's internal workflows into two distinct phases. First, the onboarding phase. This is a pilot phase where we aim to integrate approximately 10 to 12 collections. During this stage, we are not only focusing on the technical integration of the data, but also on developing and refining our integration processes. This includes identifying and correcting errors, establishing clear defined process steps, and testing our procedural framework. This phase will continue until mid-26. By this point, we will start the operational phase. We expect our integration processes to be fully established and ready to be embedded into the museum's regular workflow. Ideally, these workflows will then be executed in an automated or semi-automated manner. The second phase represents the long-term implementation supported by the support and quality assurance structures of our research division too. Collections are given the choice. They can be among the first 10 to be integrated into Specify, which means their data will be available sooner, but they may also be asked to serve as a kind of beta testers for developing and refining processes. Collections that are scheduled for the integration in the second phase will have to wait a bit longer, but they will benefit from well-established and stable procedures. Here you can see the responsibilities shared within our small team at the museum. We also communicate this info frequently in the museum, so all colleagues knew whom to approach in case of problems or questions. While my colleague Marion is our expert for setting up everything around the collection integration in Specify, Sophie takes care of the problem solving and more complex setups, as well as the communication with the third level support of Specify. I am responsible for the end user communication, onboarding, offboarding, FAQs, newsletter, workshops, and more. So basically all first level support topics that might come up. This is also the reason why I'm standing here and talking to you right now. Here you can see our current integration pipeline checklists. For each collection, we have set up an integration checklist. To ensure the successful and consistent integration of collections into Specify, we've developed what we call integration pipeline checklist, a structured approach that supports both quality and efficiency. Each collection goes through a tailored checklist that aligns with our established integration process. These checklists ensure that nothing is overlooked and that each collection is treated with the same level of care, no matter its complexity or origin. One of the key pillars of the system is transparency. We clearly define team roles and responsibilities, from data entry and validation to IT support. This fosters accountability and enables smooth cross-departmental collaboration. By applying uniform quality standards across all collections, we bring them up to the same level during the integration process. This not only improves data quality, but also builds trust in the system for both researchers and collection staff. The result of the structured approach is consistent, harmonized data that fits seamlessly into our broader digital infrastructure. It also ensures that future updates, exports, and interfaces work reliably across all collections. These checklists are a simple but powerful tool, enabling us to scale integration without sacrificing quality. Here you can see a practical example of an integration checklist, in this case used for the Hymenoptera collection at our museum. We follow a standardized checklist of 8 essential steps for every collection, regardless of type and size. These steps are assessment of current data status. That means we just look what data is there, how much data has to be integrated, what format is the data, and more. Then the schema and form configuration in Specify, statistics setup in Specify, the data import itself, controlled vocabulary implementation, data cleaning, and staff training. The structure ensures that each integration follows a clear, repeatable process, data quality, and progress control. Our overarching goal is to consolidate all collection data into a single centralized database. To maintain consistent quality across this effort, we have developed these detailed quality assurance checklists. This checklist defines precise standards for data preparation, validation, and integration. It ensures that every data set meets the same requirements regardless of its origin and supports consistent high-quality outcomes. At the same time, this checklist serves as a powerful progress monitoring tool. Because we track the completion of each individual step, we always have full transparency. We know exactly where we are with each collection in the integration process and whether we are on schedule. This approach doesn't just help us avoid delays, it also gives us the flexibility to manage unforeseen challenges by building in realistic time buffers. Let's now take a look at Specify as a data repository. Specify serves as far more than just a database. At the Natural History Museum in Berlin, it functions as a central data repository at the heart of our digital catalog infrastructure. It manages a wide range of data types, from object metadata and georeference locality data to loan records, storage information, and more. Everything is centralized within Specify, giving us a single point of access for all collection-related data. One of the key strengths of Specify is its ability to interface with other platforms and systems. For example, here at the museum, the DCI, the Digital Catalog Infrastructure, relies on Specify as its foundational data source. GBIF and Lido Specify supports export standards that allow us to share data seamlessly with global portals such as GBIF and Europeana. GIS systems. By integrating GIS tools, we can visualize collection data geographically, adding valuable spatial context to our records. This setup has several major advantages. First, it reduces data fragmentation by eliminating silos. Everyone accesses the same information in the same place. And second, it improves data reliability because Specify becomes our single source of truth. In essence, Specify helps us to connect our collections, not just internally, but also with the wider scientific and public communities. Now let's take a closer look at support and QA processes. Ensuring data quality and long-term sustainability in Specify requires robust support and quality assurance structures. We have established clear protocols for error handling, for instance, dealing with common issues like duplicate entries or inconsistent formats. Regular data review cycles help us to catch and correct issues before they spread. What's especially important, the integration checklist, which guides each collection into Specify, is being adapted into an ongoing QA checklist. This enables continuous quality control of the data already in the system, not just at the point of entry. Support structures. To support users day to day, we've built a strong internal infrastructure. A dedicated wiki and FAQ pages provide guidance for common tasks. We send regular update newsletters to keep teams informed. And we have created a support and QA landing page, a central place where users can report issues, request features, or access documentation. Onboarding is another key component. Every new staff member receives structured training, and we run regular workshops to ensure that knowledge stays fresh and up to date. Together, these elements form a sustainable support framework that empowers users and keeps our data ecosystem healthy and reliable. Let's now talk what I like to call the holy trinity of good support: quality assurance, support, infrastructure, and training. These three pillars are what keep our Specify environment running smoothly, and honestly, without one of them, the whole system starts to wobble. First, we have quality assurance. We have established clear review protocols for common issues like duplicates, and we regularly audit the data. What's more, our original integration checklist evolves into a QA checklist, so quality control becomes part of the ongoing routine, not just a one-time thing. Second, support infrastructure. This includes our internal wiki, FAQs, and newsletters to keep everyone informed. We also have set up a dedicated landing page where users can report problems, suggest features, or get updates on current issues. It's our way of making sure everyone has a voice and stays connected. And finally, training. From structured onboarding to regular workshops, we make sure our team feels confident and supported when working with Specify. Even the best software is only as good as the people who use it. And this is how we empower them. So yes, it's a bit tongue-in-cheek, but the Holy Trinity really works. Together, these elements turn Specify from a tool into a well-oiled, sustainable machine. We have established a dedicated support and QA landing page for our research division 2, who manage data management at the museum. This page acts as a central resource for addressing any technical issue or inquiries related to our data management processes at the museum, which includes Specify 7. On this platform, users can directly submit tickets and track the progress of each request in real time, ensuring transparency and efficient resolution of any issues. Here you can see the Specify support board, where the tickets or requests you recreate are logged and processed by our Specify team. Thanks to the tagging options, ticket can be shared with relevant stakeholders, and any update to a ticket automatically notify all involved parties, ensuring everyone stays up to date. Each ticket also serves as a case documentation that can be referred to later if needed. From integration requests and bug reports to inquiries about workshops or access to Specify itself, everything is managed and monitored through this board. Here you can see the Specify FAQ section in our knowledge portal. This section is continuously updated with valuable information tailored to the needs of our museum users. It includes FAQs, webinar recordings, documentations, links to the newsletter, the support board, and Specify Consortium Forum, and much more. It's a living page that grows and evolves over the time. Now let's dive into some of the lessons we have learned and the best practice we've developed through our Specify integration. First off, one of the major challenges we faced was migrating Specify 6 to 7. Specify 6 was still hosted locally, and we were heavily reliant on the IT department for troubleshooting, which caused delays and inefficiencies. Another challenge was shifting our project management approach. Initially, we planned to work on each collection one at a time, but this quickly led to bottlenecks. To address this, we switched to a more agile, flexible process using these checklists. This way, if we are waiting for feedback on a task, we can move forward with other tasks or even another collection. In terms of solution, we decided to outsource the hosting to Specify servers. This helped take a load of our team and allowed us to outsource second and third level support. Now we can simply forward any issue that we can resolve to the Specify support team, and they handle it directly. As for success strategies, we found that pilot projects were the key. We started with small pilots, which allowed us to test the processes, gather feedback, and make adjustments before scaling up. We also established strong feedback loops, ensuring that user input was continuously integrated into the process. Lastly, our recommendations are simple. Start small, scale later. It's better to take it step by step, minimizing risk, and most importantly, document everything from day one. It really helps smooth things out and prevent complications down the line. To recap, it's about the processes, the connections, and the people. Thank you.